Hi, welcome to video 8.2b part 2 using the tabular method to integrate by parts.
Use it, so don't look at it as, oh, I'm just going to do it the long way every time. And this is in the book. The key thing though is you can't always use it. It can only be used if one factor of the integral is a polynomial function like x or x squared or x to the fifth or x to the fourth, that kind of thing. Okay? Alright, so what's going to happen is the following, and it is a little system. Your book will talk about it, but let me show you how it works. So let's pretend, this is number 62, page 534, you have the integral of x cubed e to the negative 2x. This would really take a long time if you did it the long way. So what you do is you put the polynomial function in this first spot, okay, the polynomial factor of this integrand. So the polynomial goes here, and then what you're going to do with that is keep taking the derivative and taking the derivative and taking the derivative and taking the derivative. Now eventually, because it's a polynomial function, if it's like a cube, when you keep taking the derivative, it'll become a square, then a linear, then a constant, and eventually become 0. So I'm not going to give you x to the 47th, which would take 8 iterations to get to 0. Oh my. Okay. Now, the other part, the part that's not the polynomial, which is e to the negative 2x, basically dx, you're going to put it over here, and then instead of differentiating, you're going to integrate it. Because if you think about it, that's what we end up doing is when we let u equal something, we take the derivative of u, and when we let dv equal something, we integrate it to get v. So if I integrate e to the negative 2x, don't forget I will let u equal negative 2x. Derivative of that is negative 2 dx. I'll have to introduce the negative 2, counteract with negative 1/2. And then same thing, counteract with negative 1/2. Same thing, counteract with negative 1/2. Now, you're going to stop when you get to this 0. That's when you know how to stop. Now, the original sign that you're going to put here is a plus, and then they will alternate. So, and then you're going to go diagonally. I know this sounds complicated, but trust me, the other way is way longer. So you're going to take this sign, which will always be a plus, times this, times that. And then plus negative, this quantity times that quantity. Plus positive, this quantity times that quantity. Plus negative, this quantity times that quantity. And then, of course, you don't need to go any further because you'll end up with a 0. Okay, so here's your answer. It is positive x cubed times negative 1/2 e to the negative 2x. That's this right here, this whole big thing. The next term is minus 3x squared times 1/4 e to the negative 2x. That's one piece, that piece right there. And then you keep doing that. And that will be your answer. And if you did this by hand, it would take forever. So please know the tabular method. Now, when we use integrate, this is when to use integration by parts. Well, if it does not fit one of the regular integration rules in other methods, such as substitution, improper fractions, which is the dollies. So when that fails, or when you have inverse trig all by itself without its derivative. If you have the integral of an ln, not always, sometimes you can do ln's because depending on what else is there. So if you have an integral of an ln without the derivative of that ln there, or if you have a power function, which is x squared, x cubed, x times a trig function or an exponential function. So here's an example. Some people memorize the answer to this one, but you could be asked to do it by parts and actually show that work. So again, there's no point in letting dv equal ln x dx because we don't know how to integrate it. So we're going to let u equal the ln x, we'll let dv equal dx. du is therefore 1 over x, v is therefore x. There's my uv minus the integral of v du. Plug everything in. When I have my v, which is x, times my du, which is 1 over x dx, the x's will cancel. I have x ln x minus the integral of 1 dx, which is x plus c. So you might want to memorize that, but be prepared to justify why it is what it is. So here's an inverse tan. Again, we have no idea how to integrate inverse tan, so we're going to have to let it be the u, and all that's left for the dv is the dx. Derivative of inverse tan 1 over 1 plus x squared, v is x, and now you enter your uv minus the integral of v du. This time you will be able to let w, if you wish, equal the denominator. And there you have your answer for that. I think we did this one before, actually. And that's the end of video 8.2b. It is also the end of section 8.2. That's all you need to know for integration.